To quantify the amount of two phases in the binary isomorphous phase diagram, we use lever rule. Lever rule determines the relative amount of phases present in a system at equilibrium based on the conservation of mass during phase transformation. By measuring the distance on the diagram, it determines the ratio of two phases, aiding in predicting the composition of phases during heat treatment. If we consider mass balance, M, which consists of a solid phase and liquid phase, M is equals to ml plus ms. Since there is only two phases, here the sum of the phases must equal to the total mass of the alloy. If we assume an arbitrary alloy composition of X% nickel, we can say the mass of the nickel over the mass of the alloy give us our mass fraction of nickel. If we rearrange this equation to make the mass of nickel the subject, then substitute in the equation for total mass, we get the mass of nickel in the system. If we create an independent mass balance for nickel, or the total mass of nickel can be described as the mass fraction of nickel in the liquid plus the mass fraction of nickel in the solid. It is important to remember that nickel exists in both solid phase and liquid phase. We now have two independent equations which describe the mass of nickel, and if we equate the two together and rearrange them slightly, as we said earlier, in the two-phase region, the mass of liquid and the mass of solid equals to 1. Can now solve the equation for mass fraction of liquid, mass fraction of solid.